Daniel Bernoulli, Swiss mathematician born 8 February 1700 and died on 17 March 1782. Member of the Bernoulli family that gave the world 11 great mathematicians over 4 generations and who contributed significantly to the classification of differential equations and its reduction to quadratures. His research in trigonometric calculus, probability, and a now model of gases stand out, being considered one of the precursors of the kinetic theory of gases. But fundamentally, Daniel Bernoulli is known for his work in hydraulics. In 1738, in his work Hydrodynamics, Bernoulli established the law that bears his name, which states as follows. Along a flow tube, the sum of the kinetic energy, the potential energy due to gravity, and the energy pressure is constant. This law states that any variation in flow velocity leads to a variation in pressure, and conversely, that any variation in pressure leads to a variation in velocity, and has numerous applications as the hydraulic ram, the Mariotte vessel, the tubes of liquid, and the pitot tube, where if the orifice of a tube in which a liquid flows at the speed v is abruptly closed, this speed vanishes at the end is closed, and an increase in pressure result, calculated using Bernoulli's law. This considerable increase causes a water hammer at the end of the tube if another tube containing water, for example, is placed in communication with this end. This water will be seen rising through the connected tube. The pitot tube was invented by the French physicist Pitot, and its invention dates back to 1732. It allowed the speed of a current inside a horizontal tube to be measured by applying Bernoulli's principle. Bernoulli's contribution to hydraulics was to study the behavior of liquids in motion. To do this, it considered, among other things, the speed, pressure, flow, and cost of the liquid. In the study of hydrodynamics, Bernoulli's theorem deals with the law of conservation of energy is of paramount importance since it states that the sum of the kinetic potential and pressure energies of a liquid in motion in a given point is equal to that of any other points. Hydrodynamics fundamentally investigates incompressible fluids, that is, liquid, since their density practically does not vary when the pressure exerted on them changes. When a fluid is in motion, one layer resists the movement of another layer that is parallel and adjacent to it, which resistance is called viscosity. For a fluid such as a water, oil, or gasoline to flow through a pipe from the source of supply to the place of consumption, it is necessary to use pumps, since without them the forces that oppose movement between the different layers of fluid, they will prevent it. Application of hydrodynamics. The application of hydrodynamics can be seen in the design of canals, ports, presses, shed hulls, propellers, turbines, and pipelines in general. The cost occurs when a liquid flows through a pipe, which by definition is the relationship between volume of liquid flowing through a pipe and the time it takes to flow. The flow rate can also be calculated if the velocity of the liquid and the cross-sectional area of the pipe are known. The volume of the liquid that passes through points 1 to point 2 of the pipe. It is now to multiply the area, the speed of the liquid, and the time it takes to pass through the points. For physics, the word flow means the amount of liquid that passes in a certain time. Specifically, the flow rate will be the volume of liquid circulating divided by time. And with this, the biography of Daniel Bernoulli and his contributions to hydraulic area concluded in a summarized way. Bye.